we have 2 electrons here. We have 6 electrons here. That's not equal. So what we have to do then is to triple the oxidation reaction. So I can get 6 electrons on each half reaction. So that's going to give me 3 here, 6 here, and 6 here. All right? So, last thing to do, according to this, add the 2 half reactions together, eliminating the common substances on opposite sides of the arrow and adding common substances on the same sides of the arrow. So, if we take a look at this, we're going to add these 2 together. Let me put a gigantic line here. And now, we have 6 electrons on the left, 6 electrons on the right. They will cancel each other. So they will not be part of the overall reaction. We never want electrons in the overall reaction. And we have nothing else in common here, so we'll just write down what we have on each side. So over here we have 14 hydrogen ions. And we don't have to worry about aqueous, but we know all ions are going to be aqueous. Plus 3 oxalate ions. Plus dichromate ion. Got the R. Yields 2 chromium, 3 positive. And it makes no difference what order you put them down. You can put them in whatever order you want. 6 carbon dioxides and 7 waters. Now, technically you're done. But what I like to do is to make sure I've done everything correctly is double check and make sure that everything balances. Atoms, charges, both, okay? So we got 14 hydrogens here, 14 hydrogens here. I got 6, 3 times 2, 6 carbons here, 6 carbons here. I have, whoops, I forgot the 2 here, Cr2O7. I have 2 chromiums here, 2 chromiums here. My oxygen, 3 times 4 is 12. 12 plus 7 is 19. 6 times 2 is 12. 12 plus 7 is 19. The atoms balance out just fine. Now I'll check the charges. Positive 14 plus negative 6 makes positive 8. Plus negative 2 makes positive 6. Over here, 2 times positive 3 is 6. No charge, no charge. Positive 6, positive 6. This is a balanced equation. Three, 2, 1. All right, so the next thing we need to do is deal with this problem. You've already done this in your previous homework. This is what you should have gotten for your values, and most likely you already had this all corrected before you started doing this. Hopefully you have. So we need to identify the oxidation reaction and the reduction reaction. In this case, since manganese is going from 2 to 7, this is going to be Mn2 positive, yields MnO4 negative, and then this is going to go from, for reduction, PbO2 to PbSO4. Now, I'm going to give you a little heads up on this. The SO4 is going to be an issue, and so after we get done with the oxidation numbers parts of this, we're going to deal with the SO4 and show you how to deal with that. So anyway, we go over here. That is step number 2, is identifying the 2 half reactions. Step 3, make sure that your affected atom is balanced. We both have 1 manganese there, and we both have 2 or 1 leads on that, so that's balanced. The electrons then, again, go over the oxidation numbers, 2 to 7. We ignore the one that is not an oxidation number. This is just coincidentally the same as an oxidation number here. but don't get hung up on that -1 over there. It is the positive 7 that you should be identifying. 2 from 7 is 5, and this is the larger side of the oxidation number, so we put 5 electrons there. For the next one, we have positive 4 to positive 2. This is the side of the larger oxidation number. The difference between that is 2, so we're going to have 2 electrons there. Okay, it's at this point that it's going to be important that we take care of the sulfur that is not identified up here. So for the charges, we have to start including the sulfate. So I'm going to put in red here, SO4 to negative, to show that that is being done after all the oxidation numbers are completed. Okay, now we go to step 5, which is to use the hydrogen for balancing the charges. So we have a positive 2 charge right here, and we have -1 here, and we have -5 here. And actually, I should not be using circles because that means you're dealing with oxidation numbers. So we'll just say positive 2, -1 plus -5 equals -6. The difference between positive 2 and -6 is 8. 8 hydrogens we need, and we're going to put it on the negative side. And so we're going to add 8 hydrogens here. We do the same thing over here. We have -2 plus -2. And that gives us -4. And this is 0 over here, so we need 4 hydrogens. So we're going to put on the negative side here, 4 hydrogens. Remember, you always put the hydrogens on the negative side or the least positive side. They're both positive. Okay? So now is where we start putting the waters in. And so we got 8 hydrogens here. And so we'll put 4 waters over here. And as you can see, the oxygens now balance out. You have 4 oxygens on both sides, so that works out very nicely. This is a tad more complicated, but not too much. Again, we got 4 hydrogens here, so we're going to put 2 waters over here to get the hydrogens to balance out. And you see you got 6 oxygens here, and 2 plus 4, 6 oxygens there. So that's why it's real important to get that sulfate put in there. Okay? Step 7 says to go ahead and start by getting the number of electrons on each side the same. We have 5 over there, 2 over there, so the lowest number 5 and 2 go into are 10. So we're going to double this, and we're going to multiply this by 5. Alright, so when that happens, we're going to get 8, 2, 2, 10, and 16. And over here, so we multiply by 5. This will give us 20 hydrogens here, 2 sulfates here. I'm sorry, 5 sulfates there, sorry. That makes it 10 electrons, 5 lead oxides, 5 lead sulfates, and 10 waters. Turning into a mess, but here's our final outcome. We have, first of all, we got to take care of things on opposite sides of the arrow. We have 8 waters there and 10 waters there, so the overall net change then is going to be 2 waters. So I'm going to put 2 H2Os right there. We have 20 hydrogens here and 16 hydrogens there. So the net change is going to be 4 hydrogens over here. So I'll put 4 hydrogens right here. Okay? And then, of course, the electrons cancel out. We got 10 electrons here and 10 electrons here, so that cancels that out. And now I put down stuff that we have that's not reducible. And so we've got 4 hydrogens here, as I said, plus 5 water, or 5 sulfates rather, plus 5 5 lead oxides yields 2 permanganates, 2 MnO4s, negative, and 5 lead sulfates. Okay, and looking at this, I forgot the 2 Mn2 positives, so there'd be plus 2 Mn2 positive right here. And now that gives me a balanced equation, which is what I was struggling with before. So now we have truly balanced equations. So your practice problems are okay, so page 886, get that put up there. This is a smooth operation here. Practice problems. Page 886, problem number 28, A through E. Have fun.